Good afternoon, students. Am I audible? Hello? Am I audible? Hello? Hello? Anybody reply? Am I audible?
Yes, ma'am.
Okay. Thank you. So, today we are going to start with our practicals, okay? Though you are at your place, okay? Fighting. Of corona at your place, okay? Is it okay? How many patients are there? In Pandharpur, how many patients? 450. Oh, so, okay. So that's why we are struggling for our for our this practicals. And now from today onwards we will conduct our practicals, online practicals, okay? So I will be uh, executing all our code and this online meeting, and then you can see that how we are performing that, and then from that you can learn what we have to do actually when we are going to perform these experiments, okay? So first of all I will share uh, which experiments that we are going to perform, okay? So I hope my screen is visible. Yes. So, uh, in this semester we are going to perform 10 experiments. So the first experiment that we are going to perform, that is design of half adder and full adder using VHDL, okay? Then CO for this is a CO1 and CO2. These will be mapped for this particular experiment. So as we have 6 POs that we have earlier designed. The first CO, that is explain different syntax of HDL language. So whenever you are going to perform this experiment, that time you will go through various syntaxes of this VHDL language, and then that you will be able to explain, okay? At the same time, the CO2, that is nothing but design and analyze combinational logic circuits using VHDL and Verilog, okay? So here as this adder circuitry, that is nothing but a combinational circuitry, so you will be able to design that, and then after that you will be able to analyze that circuit using Verilog as well as VHDL language. So here in the first experiment we are going to consider about VHDL HDL, okay? Then the second experiment, that is design of half adder and full adder using Verilog, okay? So here the same circuit that we are going to implement with the another HDL, that is Verilog, okay? So here again CO1 and CO2, these are mapped. That means you will be able to explain about the syntaxes that we are going to use in this code. At the same time you will be able to design as well as analyze combinational logic circuit using Verilog. Okay. Then the next circuit that we are going to perform or implement here in this laboratory, that is a simulation of 4-bit parallel adder. Okay. And the COs that are mapped, that is a CO1 and CO2. Then the next experiment, that is simulation of 3:4 decoder. Here also for this combinational circuit we will require this CO1 and CO2. Then after that the fifth experiment, that is a simulation of 2-bit comparator. So for that also you will require or you will be able to explain different syntaxes that we are going to use in a HDL language, and then after that you will be able to design and analyze combinational logic circuit using VHDL or Verilog. Okay. Then the next experiment, sorry, it should be CO2. So here simulation of 4:1 multiplexer, that is the sixth experiment that we are going to perform, and for that also you will require CO1 and CO2. That will be you will be able to explain different syntaxes of HDL languages, and after that you will be able to design and analyze combinational logic circuit. Okay. Then the seventh experiment that we are going to perform, that is design of flip-flops, for which again you will be able to explain different syntaxes of HDL language, and then now here the CO3 will be mapped for this experiment, because it is a design and analysis of sequential logic circuit. Okay, as the flip flops, these are the sequential logic circuit. So because it requires memory, so it is a sequential logic circuit. So this third CO that will be marked for this particular experiment. Then eighth experiment, that is a simulation of 4-bit shift register. Again CO1 and CO3 will be mapped, and then simulation of up and down counter. Okay, so for this it will be CO1 and CO2. And the last experiment, that is a simulation of 4-bit ALU. For that CO1 and CO3, these will be mapped. Okay, so these are the 10 experiments that we are going to perform in our laboratory. Okay, so here for each of this experiment to perform, you will require PC with a Xilinx ISE project navigator software. Okay, so here in our laboratory we are using Xilinx ISE project navigator software. So you will be required that. Okay, so if anybody has that this software, then you can perform at your home with your PC, but those who are not having this software, so for them you can just see now what procedure that we are following, and after that once we rejoin in our college, then we will perform these practicals. Okay, so till then I will be just find out if any other method that we can adopt, so that you can perform these experiments with at your home also. Okay, so let us see now what we are going to do with this software. Okay, so how we are going to use this Xilinx ISE software. Okay, so here I'll show you. Here is you can see this is the icon that is present on your desktop, that is the ISE. Okay, so double click on this, it will open this window. Okay, which is the main window that you can see, or the navigator window for Xilinx. Okay, and then here whenever you want to start with a new project or new program, that time what you have to do, you have to just go to file. Okay, then new project. Okay, and then right here in this window, new project wizard that will be open, and you have to write the name for that project. Okay, so what, and the location that where you want to store it. Okay, so I'll give the name to this as a HA. Okay, so this is my name to this. Okay, I'll just give the name that is a HA underscore. I could understand that this is my project, so I'll write it as a underscore VA. Okay, so this is the name given, okay, to the project. Okay, now the location that you can select. Okay, by default it will be stored in a C colon. Okay, now here I have created one folder in the C colon which is named as a A, and in that again I have created one more folder which is named as a VAP. Okay, so here so here now whatever project that you are going to perform or that you are going to execute, that will be stored in this folder. Okay, so okay, I'll say this okay, and then this will be stored in the C colon. Okay, at A, in the folder A with the again in the folder VAP, and the name of that project, that is a HA underscore VAP. Okay, so the working directory now for this Xilinx will be this path. Okay, so this is the working directory for this project. Now if you want to write any description about your project, then you can type it here. Okay, but otherwise you can kept it blank. That will not be any effect for this project. Okay, then here you have to select HDL because we are going to top level source type, that is a HDL, because we are going to write a HDL. There are another options, that is a schematic, then EDIF or NGC oblique NGO, but as we are going to deal with a HDL, that is a hardware description language, so you need to select HDL and then click on next. Okay, so is this clear to you? What first you have to do? You have to open IC. Okay, then go to file. After that, once you open file, then go to new project. Okay, once you go to the new project, click on that, then new project wizard that will open, and then you have to give the name to that project. Okay, once you complete that, go. Once you click on next, then you will get another window that will be open, where there will be project settings that you need to set. Okay, so here you can see that there are different settings that you have to set. So here by default property name, it will take it as a value. Okay, so this is the property name. Then here evaluation development board, that we have to take as a non-specified. Okay, so you can select from these many uh, platforms, but right now here we have selected it as a non-specified. Then product category, that is a all. Okay, there are different categories that are present, that is a all, then general purpose, then automotive, then military or high reliability, and then radiation tolerant. Okay, so these are the different product categories that will be that are available in this Xilinx IC. But out of that we are selecting all. Okay, so that means we are selecting all these category combined together. So depending on which of this category we are selecting, there will be particular calibration that will be present. Okay, so but here we are selecting all. Then after that we have to select family. Okay, so these are the different families that we have in the Xilinx. Okay, here now depending on which family we are selecting, there will be RTL that will be generated. Now whenever you are selecting, select Spartan family. So we have selected Spartan 3A DSP. Then by default this in this family, whichever device is available with our version, that will be selected. So here XC 3SD18008, that device that we have to select, then package. So whatever FPGA that we are selecting, for that there is a package. So select FG676, and then speed, that is a -4, that is selected. Okay. Then after that, top level source type, that is a HDL. Okay. So as we have selected in the earlier window only, we are going with the HDL. So here it will take it as a HDL. Then Xilinx synthesis tool. Okay. So that is a XST, VHDL or Verilog. And then simulator, that is a iSim, which is a VHDL or Verilog. Okay. And then select a preferred language. Okay. So most of the time, as in our academic version, we use VHDL as the preferred language. So we are going to select VHDL as a preferred language, but you can go for this Verilog also. Okay. But as here, most of the time we are executing all these programs in a VHDL, so we will select as a preferred language, that is a VHDL. This Xilinx IC, it supports both languages, that means Verilog as well as VHDL. But out of that, for our case, we are going to select VHDL as the first preferred language. So that we are selecting here. Then the next is the property specification in project file. So for that, we are going to select all the values that we are going to select. So store all values that we are going to do. And then another option, that there is a store non-default values only, but we are going to select store all values. After that, there is a manual compile order, so deselect it, and then VHDL source analysis standard, that is a VHDL 93 that we are selecting. Okay. So this is about all the settings that we are going to do. Okay. So once we do all these settings, click on the next. Okay. Then all the summary, project summary will be displayed on your this window. Okay. In this new project wizard window, there will be project summary that will be published, and then you have to go check what you have selected in this project. Okay. So here what we have done, we have selected project name, that is a HA underscore VAP, then project path, that is a C colon /A in a VAP folder with the name, that is a HA underscore VAP, and the working directory is the same like that of the project path. Okay. And then we have selected top level source type, that is a HDL. Then we have selected device family, that is a Spartan 3A DSP. Then device, that is a XC3SD18008. Then package, that is a FG676, and speed, that is a -4. Okay. And then we have selected top level source type, that is a HDL. Then synthesis tool, that is a XST, VHDL or Verilog. At the same time, we have selected simulator, that is a iSim, VHDL or Verilog. And then preferred language, that is a VHDL. Property specification in a project file, that is a store all values. Manual compile order, that is a false. Okay, because we have not selected it, so it will show it as a false. And then VHDL source analysis standard, that is a VHDL 93. Okay. And so the message filtering, that is disabled, so it will be shown like this. So this is complete summary of your project. For each and every project that you are designing, for all of that program, once you select all the settings, you will get this type of summary. Okay. Once you get this, just complete this project, that is without clicking on finish. Okay. So click on finish, and then you will get here the name of your project, that is HA underscore VAP. So everybody is able to see this? Yes. Okay. Zoom on your screen so that you can
Yes,
see that here.
ma'am, it is visible.
Yes, you can see here your project name with that is a HA underscore VAP. Okay, so that I have given the name. You can give any name to this. Okay, so right now you must have understood that we are going to design a half adder using VHDL. Okay, now then till now whatever we have completed, is this understood? All of you are getting what I am telling? Yes, Kaustubh, are you there in the meeting? Kaustubh, Kaustubh, Kaustubh Deshpande. Renuka, हॅलो रेणुका.
हाँ मैम.
ओके, इथपर्यंत काय झालं लक्षात आलं? काय केलं आपण? हॅलो, नाही समजलं नाही म्हणून सांगा. आपण परत एकदा रिपीट करूयात की काय सांगितलं ते, म्हणजे काय करायची आहे ते प्रोसेस. बट यू जस्ट आन्सर so that I can understand that you are there in a meeting. You are just not physically present. That means for the sake of name here, that should be displayed. But you are actually there in a meeting only, okay, with your mind also. So, Vishakha, have you understood? Okay. So, shall I continue further? Nobody is responding.
Yes, ma'am. Continue.
Okay. So, now once we uh, get this window, that is a ISC project navigator window. Now after setting all the project settings, just click on this your project name and right click on that, okay, so that there will be one window open which will have this different options. Okay, so select new source option, okay, and then you will get a new window open which is new source wizard. Okay, so here there are different source types that are present in a Xilinx IC. Okay, so that is the IP, core generated and architecture wizard, then schematic. After that there is a user document, then Verilog module, Verilog test fixture, after that VHDL module, VHDL library, VHDL package, VHDL test bench and embedded processor. So these are the different source types that are present in a Xilinx. Okay. Now as here we are going to write a VHDL module or VHDL project program that we are writing. So we are going to select VHDL module here. Okay. So select VHDL module and give a name to that. Okay. So let us give the name to this file as a half underscore adder. Now whenever you are giving name to your file, remember that it should always start with a letter. Okay, and there will be only underscore special character that will be present in the this file name. Okay, the same name will be there for your entity. Okay, so here this uh, name should be written properly. Okay, only digits, letters digits and underscore, that is the special character that is allowed in the name in a VHDL. So that only you can use. Okay, so here I have used half underscore adder as the name of this file. Okay, that means the same name will be present for the entity that you are going to write. Okay, after that you have to specify the location. Okay, now whatever location you have selected for the project, that same will be selected by default. Okay, so that is the location, then add to project and then next. Okay, so click on the next. Now here actually tell me first, what are the different parts in the VHDL program? What is?
Ma'am, library. After that,
Yes, after that
entity declaration.
yes, entity declaration,
After that, architecture.
architecture. Okay, so that means there are three parts. Okay, whenever we are going for writing a VHDL code, we have three parts. First is the library declaration, then next part, that is the entity declaration, and third one, that is the architecture declaration. Okay, now that is the program that we have. So here actually whenever you are going for the VHDL program, you just don't need to add the library in this way. Okay, here you can just get a model definition from window, from once you click on the next, add the creation of new source. Okay, so here you can see one field, that is a entity name. Okay, so already whatever file name source name that we have given, it has by default taken as a name for the entity. You can keep them that name as it is, or you can change for that. But and by default architecture name, it has selected as a behavior. Okay, so you can change that name. So I'm going to change it to the data flow. Okay, so data underscore flow, that I'm giving a name to this entity. Okay, now this is a half adder circuitry. So what are the ports present in the circuitry? Nitin, can you tell me what are the different ports in uh, half adder? Hello? Hello Nitin? Payal, what are the different ports? Okay. Tell me what are the different types of ports? Shilpa, are you there in a meeting? I'm not going to mark them as a present in this class if you are not going to answer. Okay, just say at least yes, you are present in the class. If you are not knowing answer, okay, we will again
Yes,
discuss
ma'am.
about that. Yes, who's this? Shilpa?
Payal, ma'am.
Okay, Payal. Okay, do you
Payal.
know answer? Okay, Payal,
No, ma'am.
do you know answer? What are the different types of ports in this VHDL?
Some carry.
Okay, these are the then different outputs for this half adder. Okay, पण आधी आपण कुठल्या कुठल्या टाईपचे पोर्ट्स असतात, म्हणजे जसं इनपुट पोर्ट आहे, आउटपुट पोर्ट आहे, देन इन आउट पोर्ट आहे किंवा बफर आहे. सो व्हॉट आर द डिफरंट टाइप्स ऑफ पोर्ट्स?
Input and
Input,
output, ma'am.
input and
Input and
output.
output
Okay,
port.
yes, input and
And
output
output.
ports and in outputs. Okay, so these are the three different types of ports that are present. So now Okay. Tell me, for half adder, what are the input ports? How many input ports are there? Shilpa.
A Two, and ma'am. B.
A and B. These are the two
Two
inputs. Okay. So I'll give here the name A. Okay. Just if I type this, it will be considered as a first port. Okay. So now here this is the input. Okay. So I'll write make the direction for this port as a A. Okay. Now this is 1 bit half adder that I am considering. So there is no need to select this bus, and then MSB and LSB, that will not be there in this point in this port declaration. Okay, but if I would have selected this as a vector, then I have to select this as a bus. Okay, and then I have to mention range of that vector. Okay, so from the MSB to LSB. Okay, but now, right now, as it is a just 1 bit, single bit that is present, so I will not select it. I will just give the name to that port and then direction. Okay. Then the second port, that is a B. Okay, because we have two inputs, so I have selected second input, that is a B. Again I am going to select this as a input port. Okay. Then after that, uh, okay, these are the only two input ports that are present in this circuitry. Okay, now there are two output ports that are present. Okay, कुठले कुठले ports असतात output ports? Yes, sum and carry. These are the two output ports that are present. So I'll give the name S as for the sum, and now I am going to select as a output port. Okay. सो इथे मी काय केलं, मी पोर्टला नाव दिलं एस, आणि आता मात्र मी डायरेक्शन चेंज केली. नाव आय हॅव चेंज इट टू आउट. ओके, अँड देन आय गिव द नेम फॉर कॅरी ॲज अ सी आउट. ओके, अँड देन I'll write again I will select direction for this as a C out. So now here from this only you can complete your entity declaration. Okay, जे हा जर पार्ट तुम्ही कंप्लीट केला तर तुमचं काय होतं की पोर्ट डिक्लरेशनचा पार्ट कंप्लीट होतो, म्हणजेच तुमचा एंटिटी डिक्लरेशनचा पार्ट कंप्लीट होतो. ओके, सो नाउ here we have declared all the ports, so click on next. ठीक आहे, आता परत इथं आपण सगळे 1 बिट कन्सिडर करतोय, म्हणून आपण इथं कुठलाही बिटचं कन्सिडर नाही केलं. आता बाय डिफॉल्ट इट विल टेक इट ॲज अ bit. Okay, and again by default it will consider type that is a std underscore logic. Okay, so we have not selected it as a bit wise, it will by default consider as a std underscore logic. Then click on next. Okay, so now here you can see that whatever pins that you have assigned, A that is a pin which is the input, B that is again a pin which is input, S is the pin which is the output, and C out that is the output port. So that means now here whatever are the pins that you want at your design, that will be declared here. Okay, so here now again you can see that here the name of the entity, that it has a considered as a half adder, then architecture name that is a data underscore flow, and these are the different port definitions that is present. Okay, and the source directory, source type as well as source name, that is also present in this complete summary of your source. Okay, now once you check it and then click on finish. Okay, so we have clicked on finish, and then what you will find that what your program for this half adder that will be generated. Okay, so here whatever is the creation date that is displayed, then design name, module name, so all these will be present here. Now here you can see that by default this library IEEE is added to this program, and as well as the package that is IEEE dot std underscore logic underscore 1164 dot all, that is also by default added to this. Okay. Now whenever you want to comment in a VHDL, that time you have to give two hyphens. Okay, so here you can see that two dash that are present, so that will indicate it as a comment. Okay, otherwise it will be disabled. So just this is a comment, so I will keep it as it is, so that two dash or two hyphens that are present. Okay, now if you want to use certain another libraries, then that are also added, but as we don't want here, you can see that this numeric underscore std, that package is that also present here, but as we don't need it in this program, so it is a disabled, so it is considered as a comment. Okay, so we will keep these comments as it is. Okay, so for simplicity right now, so that we will not lose any of the data right now. Okay, or otherwise you can delete it and then make your program simple one. Okay, then after that, here you can see that whatever you have mentioned while declaring your new source, that time whatever ports that you have defined, that is already mentioned in now entity. Okay, so you can see that your name entity, this is the keyword that it has been selected, then the name of this entity, that is a half underscore adder is, and then you can see it has been all the ports that are declared in a port entity. Okay, and then it is a end of this entity, that is a half adder, and after that it has been started with the architecture declaration. Now as we have mentioned that architecture name, that is a data underscore flow, so it has taken as a architecture data underscore flow of half adder is, and then begin. Okay, now we need to write here whatever we want to एक्झिक्यूट. ओके, जे काही तुमचे स्टेटमेंट्स येणार आहेत ते आता तुम्हाला आर्किटेक्चरमध्ये लिहायचे आहेत. इथंपर्यंतचं काम तुमचं खूप इझी होतं की तुम्हाला माहिती आहे की मला कुठले इनपुट पोर्ट्स पाहिजेत, मला माहिती आहे कुठले मला आउटपुट पोर्ट्स पाहिजेत, आणि त्याच्यावरून मला एंटिटीचं नेम आणि फक्त आर्किटेक्चरचं नेम डिफाईन करायचं होतं. ते मी तेवढं सिम्पली केलेलं आहे. ओके, so that program is now generated, and now whatever boolean expressions that you need to be present in your architecture, किंवा तुम्हाला जी काही प्रोसेस व्हायला पाहिजे आहे तुमच्या व्हेरिएबल्स वरती, ते तुम्ही कुठे लिहिणार आहे, आर्किटेक्चर मध्ये लिहिणार आहे, आणि कधी लिहिणार आहे तर बिगिन नंतर लिहिणार आहे. ओके, सो नाउ ऑल युअर स्टेटमेंट्स दॅट शुड बी प्रेझेंट आफ्टर दिस बिगिन कीवर्ड. नाउ टेल मी what I should write here. This is a half adder. We have discussed this so many times. So now tell me what should be expressions present in this. Okay, we have, as the name suggests, that it is a data flow modeling. So that means we need to express this in terms of Boolean expression. Okay, so output should be expressed in this architecture in terms of Boolean expression. So tell me what should be the syntaxes here.
Sum is equal to
Okay,
A
I have
XOR
given the
B.
name S, so it should be S. So and then I need to use a assignment statement, so less than and equal to. Okay, so that should be there, and then after that A XOR, sorry, it should be XOR B. Okay, okay, even though I make it as a capital, that will not make difference to VHDL, because as I have earlier stated that VHDL is a case insensitive. That means तुम्ही आधी कुठल्याही केसमधलं जरी नाव दिलं असेल पण आता तुम्ही दुसऱ्या केसमध्ये देत असाल, काहीही फरक पडणार नाही. इट विल बी कन्सिडर्ड ॲज अ, म्हणजे स्मॉल ए इट विल बी कन्सिडर्ड ॲज अ कॅपिटल ए ओनली. ओके, सो दॅट विल नॉट मेक मच डिफरन्स, बट स्टिल I am writing it in the same case that I have used earlier. Excuse. So S will be assigned to A XOR B, and then complete the statement with semicolon. Okay. After that, in the next line, what will be there? out that is assigned to, what is the Boolean expression?
A and B.
A and B. Okay. Now what do you observe in this program? ओके, दिस कम्प्लीट्स आवर प्रोग्राम. इथे तुमच्या लक्षात येईल खाली काय आहे, एंड ऑफ द डेटा फ्लो, म्हणजे इथे काय झालं, तुमचा आर्किटेक्चर एंड झालेला आहे. ओके, नाउ व्हॉट डू यू ऑब्झर्व हिअर? All the keywords that you find in a blue color. Okay, here this data type that is in a pink color. Okay, and now here you can see that though we have not specified this type, but it has taken it as a std underscore logic. Okay, so by default this Xilinx that is considering this type as a VHDL underscore logic. If it is a vector, then it will, instead of considering it as a bit vector, it will consider as a std underscore logic underscore vector, because whenever we are considering bit type, then it will take only two values, that is a 0 or 1, but for another values it will not say it is of which type. But whenever we are saying about std underscore logic, it will take different 9 values. Okay, so that means don't care, then tri-state, all these different values that will be considered whenever we are considering std underscore logic. So these are the, this is the program which we have written for half adder. Okay, now once you complete this program, save it. Okay, so you can click on this save button, or you can go from this and then save. Okay, but as this is the shortcut that is present here, so I have selected that. So just click on save button. Okay, now we need to check the syntax of this program, whether it is correct or not. Okay, so click on this, expand this synthesize dash xst. Okay, and here you will find that there are different 4 options that are present, that is a view RTL schematic, then view technology schematic, then check syntax and generate post synthesis. Okay, so these 4 different options that you will find. Okay, so out of that, double click on this check syntax. Okay, and then you will find that there is certain processing symbol that is present over there. Okay, so whenever you are going to check for this till the completion of the syntax checking, and then if your syntax is correct, then it will show it as a correct, that means this correct mark that will be shown over here with a in a green color. Okay, if it is a wrong, then it will show it as a cross mark, that means it is a wrong, and then where it is wrong, that will be displayed in the errors field. Okay, so इथे तुमच्या ज्या काही एरर्स आहेत प्रोग्राम मधल्या त्या डिस्प्ले होतील. ओके, नाउ वी हॅव completed our checking of the syntax. So now it is clear that here, as it is a correct sign that is present, that you can see here, so our syntax is correct. So now let us go for the viewing RTL schematic. Okay, so how our register transfer logic, that schematic is present, that we are going to check. Okay, so now click on this view RTL schematic. Now you will find that it is checking for the complete synthesizing. Okay, so now we have completed our synthesizing of this program, and then after that you will get this window open, that is a set RTL or text viewer startup mode. Okay, so here you need to select how the RTL or text viewer behaves when it is initially invoked. Okay, so the startup mode, there are 2 options. One is the start with the Explorer wizard, that means in this mode the Explorer wizard is the initial screen and allows you to select the elements with that you want to see on the initial schematic. Okay, and the another option, that is a start with the schematic of the top level block. So in this mode the Explorer wizard is bypassed and an initial schematic is created with only the top level block displayed. You can then use the logic expansion capabilities of the viewer to start expanding from the top level block. Okay. So, here we are going to select start with the schematic of the top level block. Okay. And then you can select this. Okay, if you want to have this window every time, then you can select this checkbox, that is show this dialog on the start way, otherwise you can disable this. Okay, I have selected it and I am going to keep it as it is. Okay, and then click on OK. So, now you will find this window that is present. Okay, now here you can see this is the RTL for the half adder. Okay, here you can see there are two inputs, that is now you can, whenever you are your cursor is on that pin, you can see that what it is. Okay, so my cursor is now on A, so that it is displaying that it is a input pin, that is a A. Okay, now if my cursor is on B, it will show it is a input pin B. Then now it is a C out pin, output pin C out, and this is the output pin, that is a S, that means sum. Okay. So, this is the block diagram of half adder. Now, if once you double click on that symbol, you will get this inside diagram. Okay, whatever is in that RTL. Okay, so how your logic is transferring from the register, that you can see here. Okay, so here these is the AND gate which has the inputs, that is a A and B, and output of that is a C out. Okay. Now, as you know that XOR is again the combinational circuit, so there is a one box that is shown over here. So, again if you click on that, you will get the XOR circuitry. Okay. So, here you can see this is a XOR block which is implemented with these gates. Okay. So, one OR gate and this AND gate which has one active low input. So, that is shown over here. Okay. So, this is the complete RTL circuitry for the half adder. Okay. So, now this is how we have completed our synthesizing of this half adder. Okay. Now, after that, now once we have completed, now we have found out that this, after designing or after fabrication, our circuit is like this. Okay. So, you can go for the technology schematic also. Okay. So, if you are selecting this view technology schematic, and then again selecting the start with the schematic of the top level block, clicking on OK, you will get this block again. So, this which is showing outer pins of this half adder, where input pins as well as output pins, and once you click on this, you will get you will get this diagram. Okay. So, that is the technology schematic, where actually in the RTL schematic you will not see this type of buffers. Okay. But actually whenever we are giving input, it means transferred from input pin to actually input wire. Okay. So, for this gate, so there is in between input buffer that is present, so that is shown over here. So, this is the technology view of schematic view of this half adder. Okay. We will not go in much detail about this, but I am just showing this how it look like. Okay. So, this is the technology schematic. Okay. So, here we have completed the simulation part of this, but now actually we need to see whether this circuit responding correctly or not whenever we are giving particular input. Okay. So, that means whatever we are learning now in the our topic, that is the testing of circuits, logic circuits. So in that, how we are just discussing about how to test that. Okay, so like that way we need to give certain stimulus, that is inputs, to this input pins of this design, and then we have to check what is the output. Okay, so for that we need to write a test bench for this circuit. Okay, so how to write test bench for this circuit, that we will discuss in the next part of our fifth topic, that is a testing of logic circuits. And then in the next practical we will discuss about how to write test bench for this circuit. Okay, so for today we will stop here. Okay, if you have any doubt about this, you can ask me. Any doubt? हॅलो, इथपर्यंत कोणाला डाऊट आहे का?